we're going to look at logarithms today and talk about how logarithms and exponential functions are related. So those two functions are inverse functions of each other, which means we can take one of them and write it in the form of the other one. We've also looked at their graphs and talked about the inverse, them being inverse functions. So when we write a logarithm, and a lot of times, we'll just write logs or abbreviate that way. But a logarithm of base b looks like log base b of x equals y. And we can write it as y equals log base b of x. So it could be written either way. B is greater than 0. B can't be equal to 1. And x has to be greater than 0. So if the number that's in here, or when I evaluate it and plug in a number for x, if this argument right here, so that's called an argument, if that argument is negative or 0, we kick it out. It's not possible, not a solution. All right, so this logarithmic function is the inverse of an exponential function. All right, so when I have a logarithmic function like log base 3 of 81 is equal to 4. So log base 3 of 81 is equal to 4. And I want to change to exponential. The base is the base. All right, that doesn't change. So b is b. So I'm going to start with my base to change to exponential. So 3 is my base. My exponent for 3 is 4. And it's equal to the argument. Right? That is a true statement. 3 to the 4th is 81. So I can change back and forth between exponential functions and logarithmic functions. And that can help me solve for a logarithm. So if I have something like log base 5 of 125 that I can't put on my calculator and I want to evaluate that, I usually put equals a variable, so I usually use x, and then I can change to exponential. So 5 to the x equals 125. All right, so now I have to make my bases the same so I can figure out what my exponent is. So I know that 125 can be written as 5 to the 3rd. So my bases are the same. Now I can set my exponents equal to each other. So I know x is equal to 3. So 5 to the 3rd is 125. So just a reminder, if we see log 100, that means my base is 10. This is my common logarithm. That's not written there, but my base is 10. So 10 to the x equals 100. We know x has to be 2 for that to be true. If I see something like natural log, the natural log, the base is e. So I have e to the x equals e to the first power. If there's no power there, we write a power. So x has to be 1. So think about that. If my base is the same as my argument, it's 1. Is that true all the time? So log base 7 of 7. Is that equal to 1? Well, let's change it to exponential and see. 7 to the x equals 7 to the first. So yes. So if my base and my argument are the same number, you can simplify that to just 1. All right. Let's try another one. All right, let's try 25. Let's try to solve an equation. Equals 10 to the x minus 1. All right, so we are going to change this to logarithmic form. All right, so that's going the other way. So we changed from log to exponential. Now can we change from exponential to logarithmic? Well, this is my base. So I have log base 10. I'm not going to write anything because it's common logarithm. My argument is over here, so you can rewrite it if you need to. So I have my base, what it's equal to, and my argument. When I change it to exponential is what I mean. All right, so I have my logarithm. I'm changing it to logarithmic form. So I have log base 10 of 25 is equal to x minus 1. All right, so that's just undoing what we were doing just a minute ago. So I can evaluate log 25 on my calculator, but I can also just solve for x from right here. So I have log 25. I'm going to add 1 to both sides. And now I can throw this on my calculator and round to the nearest whatever they say. Let's go nearest thousandth. So the log button is on the left side of your calculator. It just says log. So log 25 and then plus 1. It'll probably throw a parenthesis on here, so we can just parenthesis the 25 because we don't want the 1 in there. So log base 25, log base 10 of 25 and then plus 1. So you should get 2.398 when you round to the nearest thousandth. Okay, let's try one more with natural log. So natural log of 2x plus 3. Natural log of 2x plus 3 equals 4. All right, so let's change this to exponential. What's my base? Yep, it's e. So I have e to the 4th equals 2x plus 3. Now I can throw this on my calculator for sure. We can solve for x. Remember, e is a number, and we have an e to the x where we can put a 4 in there. But let's get everything to one side before we put that on our calculator. All right, so my steps to solve, I have 2 steps to get x by itself. I need to subtract 3. So I'm going to subtract 3 from both sides, and then I'm going to divide by 2. So remember, e is 2.718, and it's irrational, so it keeps going. But I can just use the e button on my calculator. So I'm going to take 2.718 blah, blah, blah to the 4th minus 3 and then divide all of that by 2. And so we should get about 25.799. All right, so that's a little intro to switching things from exponential to logarithmic form and logarithmic to exponential form, and then being able to solve some equations and also putting them on your calculator and evaluating. All right, see you guys soon.